This video is for class 9 physics, and today we are doing the reason for upthrust. Now, before watching this video, please watch those videos, those 3 videos which I have already made for this chapter, that is for the upthrust. Now, if you have watched, then I think you'll relate it and you'll understand the topic which you are discussing right now. Now we have read that in a liquid contained in a vessel exerts pressure at all points in all directions. Now the pressure given by the liquid is equal in all the directions for a given point. The pressure at a point in a liquid is same in all the directions, upwards, downwards, sideways, which you have done in the previous chapter, which is chapter number 4. It increases with the depth inside the liquid. As the object goes down in the liquid, the pressure increases. So when a body, say a block of area of cross section A, is immersed in a liquid as shown in the figure 5.3 right here. So whenever an object is immersed in a liquid, so the liquid will exert pressure right from all the sides. Okay, that's what the liquid pressure says. And as this object goes down, right, as this object goes down, the pressure exerted by the liquid on the object will be more and more. Okay, now let us try to understand how this thing is related to the upthrust. Now the pressure P2 exerted upwards on the lower face of the block, which is at a greater depth, is more than the pressure P1 exerted downwards on the upper face of the block, which is at the lesser depth. Thus there is a difference in pressure, which is P2 minus P1, between the lower and the upper faces of the block. Okay, let us try to understand this with the help of this diagram. Now as you can see, this is the upper face, and the liquid above the upper face is this, right? Let it be H1, smaller height. But now if I consider the lower face, now the liquid above the lower face is here till here, so that is H2, right? Since H2 is greater than H1, therefore this pressure P2 should also be larger than pressure P1, because as you all know, as the object goes deeper in the liquid, the pressure felt by the object is more. So here you can see the lower face is facing more pressure than the upper face of the object. I hope you understood till here. Now there is a difference of pressure, and the difference of pressure will be P2 minus P1, right? I hope you have understood till here. Since force equal to pressure into area, from the formula P equals to F upon A, right? From the formula pressure equals to F upon A, we shall get force equals to pressure into area. Now the difference in pressure due to the liquid on the two faces of the block causes a net upward force, that is upthrust, which should be equal to P2 minus P1, which is the difference in the pressure multiplied the area on the body. However, the thrust on the side walls of the body get neutralized as they are equal in magnitude and opposite in direction. Okay, let us try to understand this. Now as you can see, the upper face is facing a pressure of P1, and the lower one is facing pressure of P2, and we have already proved that P2 is more than P1, right? Now as you all know, force should be equal to pressure multiplied by area, so force on the lower face should be more than the force on the upper face. This P1 is created because of force F1, and this P2 is created because of this force F2. Now as F2 is more than F1, right, so there will be a difference of force, which is F2 minus F1, right? Now because of this difference, the body will be pushed a little bit upwards, okay, and that upward force is known as upthrust. So therefore upthrust comes into play because of the difference of pressure. right? Upthrust comes into play because of the difference of pressure. So I hope you understood the reason for upthrust. Now the last line says that the forces on the sides of the container, the object, gets cancelled out, because as you can see, they are at the same depth, so pressure also should be same, and they are having the same area, so the area also should be same. Therefore the force on this side should be same on this side, hence they get cancelled out. So the last note, okay, if a lamina, that is thin sheet, is immersed in a liquid, the pressure on its both surfaces will be nearly same. So the liquid will exert negligible upthrust on it, causing it to sink into the liquid due to its own weight. That means if I take a plate, there will be no height difference. Instead of a block, suppose only a single plate was taken, so the difference in the height of the liquid column here is negligible, right? Okay, is negligible, only the thickness of this line. So because of this less difference in the height, there will be less difference of the pressure, hence there will be less difference of the force, so the upthrust will be negligible. Okay, this much for this video. Thank you so much.